All right, so thank you everyone, and I think people are having a little, hard time finding a parking spot. Hopefully they will get here before too long. And my name is Sumi Han, and I'm from SEDAC, Smart Energy Design Assistance Center at the University of Illinois. And there's a Ryan, and we both are gonna cover today's session. So I briefly mentioned that I am from SEDAC and we are from U of I, and I'm just curious if you guys aware of us or know of us. Anybody that worked with SEDAC and know SEDAC? Great. If not, so we are a applied research program at the University of Illinois at Urbana-Champaign. And we also work with our private partners. So it is very unique setup. We have public and private partnership. And our mission is to improve the energy efficiency of the Illinois and reduce the energy footprint of the Illinois. And before the change, meaning when DCU was the energy office, we worked with DCU to work for the public sector energy efficiency mainly. And now things have changed and we have many more things. And one of the new things that we are doing is to providing this energy code workshop. So we have actually a program. It's not just a workshop. We do provide many other things for the energy code training. So I don't know if you guys are aware, but so previously Illinois State Office of Energy was under DCEO. Now it has changed. So now State Energy Office is in Illinois EPA, and now we are working with EPA to provide the technical support and the training for the energy code. So as I mentioned, not only just an in-person workshop, we have a technical support. We have 800 number. So if you have any questions about the energy code, you can call us. And actually, email is a better way. It's energycode@sedac.org. So you can ask questions through this email, and we have team of staff who is looking at the questions that come in, and we kind of discuss and we try to give you a very coherent answer for that. So we are receiving questions from code officials, architects, engineers, and sometimes homeowners too. So feel free to contact us if you have any questions. And also, not only just questions, but if you have any stories to share, if you feel like this is very important information that you want to share with others, please let us know so we can be a kind of information hub for the energy code in Illinois. So we also have a website, and we do provide webinars. Actually, next week, November 14th, we are having a webinar. It's for the residential and IRC. So if you are interested in residential energy code, please sign up for the workshop. It's November 14th at noon. And also, we have online education modules. So it's not, it is something that you can sign up, and then you can kind of, go along for your pace. So you can kind of start and stop and pick it up. So this is our website for the energy code training program. So if you see on the left, we have some general information in Illinois Energy Code, and the workshop, webinar, and FAQ, and contact us. So I want to spend a few minutes talking about our online modules, because this is something new. Traditionally energy code trainings were done like this setup, in-person workshop, but now we're trying to have many different mode of learning, and this is online module, so it is free. You can just sign up, and each module probably will take an hour or hour and a half for you to finish. And this is a great, like a basic model. So if you are architect or engineer who are not familiar with the energy code, this is a good start. So we have one residential module and then 3 commercial modules, one for envelope and lighting and HVAC. So if you sign up for one of the modules, this is how the module looks like. You have navigation tool, you can go to, go jump back and forth. And there are some contents here. And at the end of the module, there are quiz. There are like 10 questions. So if you have 7 or more correct answers, you will pass. And then we will send you the certificate. But don't worry, if you did not pass, then you can take it as many times as you want. So we see this, some of the community colleges, they signed up for the students. So students kind of learn this way for the energy code. So we thought this is really great option for students too. So before we talk about nitty-gritty details of energy code, I want to just briefly talk about why we even need to talk about energy code, why it is important. Short answer is because building uses a lot of energy and create a lot of emissions. That's why. So just quickly, the commercial and residential buildings. The buildings in the U.S. consumes how much of energy of the nation's total primary energy? Yes?
40%.
40%. Sound about right? 50? 70.
70.
Yeah. Actually, 40. 40 is a correct answer. That's a lot, actually. So, rest of the 60%, that's from industry and transportation. So that's another 2/3. How about electricity? Building consumes how much of electricity consumes in the U.S.? 20? 60. Actually, it's 70. So because it is a lot if we are looking at just electricity, because transportation doesn't really count up for the electricity. So electricity building actually consumes 70%. That is a lot. And then how about CO2 emission? How about what percent? 40. Oh my God. Yes, you got 3. Check, check, check. 40% of CO2 emission is from actually the building. That is actually a lot. So that's why energy code is important. That's why building energy code is important. And that's why we're here. So this is just a graph to show the same information or similar information. So you can see, actually commercial, residential, if you combine, that's about 70%. So what's the benefit if you comply with the energy code? What is the benefit that you're getting? So this is based on the DOE research. And they said if all the buildings in the US comply with the current energy code and keep that trend, then they say that it will reduce the energy consumption by a lot, 3.5 quad BTU per year. And then it will also reduce CO2 emission, because approximately 3%. And then actually the money, if all the buildings in the US comply with the energy code, actually it's going to be saving almost $30 billion by 2030. So now we're going to talk about Illinois Energy Conservation Code. So that's slightly different from IECC. IECC, when we say IECC, it's International Energy Conservation Code. That's the model code, standard code. But Illinois Energy Conservation Code is slightly different from IECC, and we're going to talk about it, how and why.
So this is a good website for you to go to learn the basics of Illinois Energy Conservation Code. So the CDB, Capital Development Board website, they are in charge of adopting and kind of processing that legal stuff in Illinois. So if you go there and they have a description on Illinois Energy Conservation Code, and that says Illinois Energy Conservation Code requires design and construction professions to follow the latest published edition of Iecc and ASHRAE 90.1, including amendments adopted by the CDB. And they say state-funded facilities must comply with ASHRAE 90.1. And then privately funded commercial facilities, so all the commercial facilities other than state-funded facility must follow Iecc. And then residential, you follow Iecc. So that's kind of like a big picture item, like what is Illinois Energy Conservation Code and what model code you're supposed to follow. So one thing that I want to mention, so this is current information. So here, state-funded facility, it said ASHRAE 90.1. So that is still true, but for the updated code, so CDB and the Code Advisory Council, they had a meeting and they decided to go for Iecc, for state-funded building 2. So to make things simpler, I think. But you can, if you want, you can still follow 90.1, but that's not required. So state facility as well as other commercial facilities, Iecc is the model code. Any questions? So this is new.
Excuse me, when you refer to Iecc, is that the energy code or the Illinois or the international? Because you say
Right here is the Iecc. Whenever you see Iecc, it is mostly International Energy Conservation Code. Illinois Energy Conservation Code, sometimes they say IECC, or not to confuse anybody else, we just spell it out all Illinois Energy Conservation Code. But if you see IECC, it's an International Energy Conservation Code, model code. So just to update you on what's going on in Illinois Energy Conservation Code. So updated Illinois Energy Conservation Code based on 2018 IECC is anticipated to be effective in March 2019. So it is coming along, quick, few more months. So the current situation is that, the Illinois Energy Efficient Building Act, it requires the Illinois Code Advisory Council to review and adopt the most current version of Iecc, which is 2018, and within 1 year after the Iecc book has published. So 2018 Iecc book was published in September 2017. So within a year, which is by September 2018, which they did. So they reviewed, and there are some proposals for the Illinois amendment, and they kind of, going through that process. And then it will be effective within 6 months. So 6 months from the September 2018, it'll be March of 2019. Will be effective unless JCAR voted down, which we don't expect to happen. But it is a process, so it is not 100% confirmed because it didn't go through the JCAR yet. But once they do, then it will be effective in March of 2019. So, as I mentioned, the model code, Iecc, and Illinois Energy Conservation Code is different because we have our own amendment. That's what it makes it different. For this cycle, the proposal is already, the deadline for you to submit the proposal to the change to the 2018 has already passed. It was like a March 2018. But next time, if you are interested in participating in Illinois amendment proposal review process, this is the simple paperwork that you need to fill out. So basically what it is you just give your contact information and you just write down what section of the model code, in this case 2018 ICC, that you wanna change, and then how you wanna change, and what's the reason, and what's the related cost impact. So if you submit this to the council, and anybody could submit this proposal, and they will go through the process, review it, and vote it, and then go through, and then they will decide what proposal they will accept and what proposal they will not, and that way they will update the amendment for each cycle. Any questions? So just to give you an idea about the examples of Illinois amendments. So this is the Illinois amendment based on 2015 ICC, so the current Illinois Energy Conservation Code. So for instance, this is the residential provision. It's about the building thermal envelope, and this is the insulation and fenestration requirement by component. So what they did, so Illinois is climate zone 4 and 5, and then the ICC used to say, zone 4 is 0.4 is the requirement, and then zone 5 was none, there's no requirement. They felt that it will be confusing for the builders and designers if we have a different requirement per zone, Southern Illinois versus Northern Illinois. So they try to make it simple. So zone 4, ICC says 0.4, but Illinois amended out, saying that no, it'll be the same. Same goes here. The idea was to make it simple. So things like this little numbers, so when you look for the requirement for the Illinois Energy Conservation Code, you need to look at the ICC book, and also you need to look at the Illinois amendment copy. And that is available on the CDB website and also our website. And another example on Illinois amendment, so there's those numbers that they amended out or in, and also there are some kind of like admin type of or definition type of changes that they make for Illinois specific. And for instance, the definition of residential building. So the part that it was struck out, that is a language from the IECC, and the part that is added in is Illinois amendment. So basically what it says is residential building in Illinois, it means, the residential occupancy in 3 or less height in Illinois, but there's another exception. In city of Chicago, it says, the jurisdiction having a population of 1 million, which is, there's only one jurisdiction in Illinois, which is Chicago. It's a 4 or less is residential. So these type of things are the amendment, the Illinois specific amendment that you need to be aware of. So speaking of Chicago, so in general you can think there's a model code, IECC, and Illinois adopts a model code with some of the Illinois specific, the requirements or language change. And on top of that, Chicago has their own special thing, and they call it a Chicago Energy Conservation Code, or sometimes we call it a Chicago Amendment. So if your project is in Chicago, then you need to look at 2. One is IECC book, and then Chicago Building Code or Chicago Amendment. If your project is outside of Chicago, city of Chicago, then you need to look at 2. One is IECC and then Illinois Amendment. Questions? Yes?
So if you're in Chicago, you look at all 3?
Well, it is, but most of like a Chicago amendment kind of covers the amendment too. So, yeah. Any other questions? It's not that confusing yet, correct? Hopefully. So this is a screenshot from the Chicago Building Department. So it explains well about what is Chicago Energy Conservation Code and what kind of process that you need to go through to get a permit and stuff. And we will talk about a compliance statement form a little bit later, more in detail. But it says, you know, this is a process that you need to go through, and I want to point this one out. The last, it said free technical assistance for design professional. It says it is done by U of I SEDAC, so that's us. So in Illinois, for the energy code training and technical support, we are the hub. So if you have questions, let us know. So this is an example of Chicago Energy Code or Chicago Amendment. So they're just changing some language, saying code official, City of Chicago, department building, or building commissioner. And in terms of historic buildings, if it is listed as a Chicago landmark, or if it's listed as in the Chicago Historic Resources Survey, it is, you know, historic building in Chicago. Another important thing in the Chicago Building Code is this one, the roof solar reflectance and thermal emittance. That's the Iecc section. So Chicago amended this out and give it even a different name, and it's called Urban Heat Island Provision. So originally Iecc, this section only applies to like zone 1 and 2, I believe, but Chicago now is saying, okay, if your project is in Chicago, then you need to follow this heat island provision. This is a requirement, and there are some requirement language here. So Illinois amendment doesn't have this. Only Chicago amendment or Chicago Energy Code has this one. And another big change that I want to mention, and how many of you are familiar with REP, Registered Energy Professional? Great. So now it's gone. So before you to process your permit or plan review, what you need to do was this one-page document signed by REP, which is Registered Energy Professional. Registered Energy Professional is the licensed architect or engineer, and if you went through at least one energy code training, then you are REP. And then Chicago Building Department used to keep the list of REPs, and then you can only sign this document if you're listed on there. Now, they changed it. So this change was happened in June 2018 of this month, so this is pretty new. So you don't need to be listed as REP anymore. So this is a new form. You can download it from the Chicago Building Department. What has changed? So this is just, kind of similar language, your contact information, and this one you need to be the same, either licensed architect or licensed engineer. But there's no requirement for you to be listed as REP. And then they added this compliance method here, which I think is a great idea. So effective of June 20, you need to use this form. And as I said, this two form, one for residential and one for commercial. So top part is the same for residential and commercial. This bottom part is different from residential and commercial. So if I blow up that bottom part for the commercial, what it is a compliance method. So you need to check out of this what is a compliance method that you are using to comply with Illinois Energy Code.
It's only one, right?
Correct. You check only one out of this. So it's either ComCheck, it's a recommended, I feel like probably like an 80-90% of the project do comp check. But just in case, if you want to do other than comp check, you can check either prescriptive path, and there are two under prescriptive path, which is one is simple HVAC, complex HVAC, but basically either comp check or prescriptive or performance or ASHRAE 90.1. So you pick and choose what compliance path you are choosing, and then you need to show the document that you are complying with those requirements. And for the residential, similar things. So you either check red check, which is most of the projects are, submitting this red check report for the compliance. But if you're not, then you can do prescriptive method or performance method. So under performance, there are two. One is simulated performance method, and second one is design rating index. You can think these two as performance, meaning like energy code. So last one, ERI, is a HERS rating. So if you're doing HERS rating, and if that's the compliance path that you chose, then you check this. And the part that I like in the residential, they have snapshot, a very short, it's not long, but it says the following mandatory, the provisions also apply to all residential projects, meaning no matter which path you are taking, these are mandatory. And you can kind of, there are some lists of sections. It doesn't, explain all the details, but it is a good starting point for you to make sure if you comply with this. Yes?
Currently, the city of Chicago doesn't really enforce duct testing or blower door testing. However, it's mandatory. Can you speak at all to that?
Well, I don't know about so Illinois-wide, the Illinois amendment proposal was reviewed and kind of, in the process being confirmed, but I don't know exactly about City of Chicago, because last time when I talked to City of Chicago building officials, they were even saying something like they might not, kind of in sync with Illinois, because every 3 years is kind of too much. So they were even thinking about maybe we're going to go every 6 years, but I don't know where they are at. So if you know any more detail about what's happening in the Chicago Building Department, let me know, please. But I will, yes.
Sorry.
It's all right.
This is a different question.
Good, it's all right.
For the commercial compliance method in Chicago, I noticed that they also added the 90.1 performance rating method
Right.
of the F.
Right.
The last one, which is really funny.
Yeah. Right, okay. So ASHRAE 90.1 Appendix G wasn't typically the compliance path so far. That's my understanding. It was just for the lead or energy performance. It wasn't a compliance path. And that's how it's written in the ASHRAE book too. So change to the ASHRAE 90.1 2016, they actually changed it. So if you follow the ASHRAE route and ASHRAE 90.1 2016, actually Appendix G is the one of the compliance path. So I cannot speak for the city of Chicago, but my guess is that this was added because now they just updated and they just looked at the next code and maybe they added, but that's my guess. But technically 2016 Appendix G is one of the compliance paths, but 2013 is not. So, yeah. So that was, kind of like admin side of it or the process side of it and some details or compliance paths for the Illinois Energy Conservation Code. And now I'm going to briefly talk about IECC, which is International Energy Code. Not to confuse you too much, this is a model code. And I'm going to just talk about some big picture item, and Ryan is going to actually take over and talk about like item by item and changes. So speaking of compliance path, so according to our model code, IECC, 2018 IECC, you can choose 3 paths. In general, you know, I can say there are 3 paths that you can choose from. One is you can open up the book and it says, if you want, you can follow the ASHRAE 90.1 2016. And you can close the IECC book and you can go to ASHRAE. So that's a one compliance path for commercial project. Oops. And second compliance path is prescriptive. And then third one is performance. So prescriptive path, if you pick the prescriptive path, then you need to follow these requirements: section envelope, mechanical service water heating, lighting, and plus you need to pick one additional efficiency package, which are under C406. So you could pick either more efficient HVAC performance, or more efficient lighting, or more efficient lighting control, or you could choose on-site supply or renewable energy, or you could have dedicated outdoor air system, or you could have high efficient service water heating, or these 2 are the new to 2018 IECC, so they added 2 more options for you to choose from if you pick the prescriptive path. So the one is enhanced envelope performance, or the second one is reduced air infiltration. So there are 1, 2, 3, 4, 5, 6, 7, 8 additional efficiency package for you to choose from. So if you are going down to the prescriptive path, you need to pick at least one of these. And let's say that you decide to go for the performance path, then you need to comply with all of these. And then bottom line, you need to show that your building consumes less than like 85% than the standard. So that's like a big picture. Of course, if you go in detail, there are many confusing parts, but this is just like if you want to remember the big picture, these are 3 simple routes. And then residential. So residential, in terms of big picture, actually 2. One is prescriptive, the other one is performance. But inside the performance, 2 different performance paths. One is simulated performance, and then the other one is ERI. This is a HERS. So if you go through prescriptive, then you need to follow all the prescriptive requirements as well as all the mandatory requirements. How many of you have actually worked, and then your project was following the HERS rating compliance path for residential? Oh, actually, I forgot to ask. So how many of you are interested in residential provisions of the energy code? And commercial? Okay, all right, I thought so. So we're gonna both cover commercial and residential, but probably we'll spend more time on commercial. So those are the 2 big, like a compliance paths if you're in commercial or residential. But sometimes, actually, if you need to follow the commercial provision or residential provision, isn't that clear cut? At least it was for me. So I just want to go over to make sure that we are on the same page. So residential building is a detached 1-family or 2-family dwellings, and any building 3 stories or less. And in Chicago, 4 or less. That's the definition of residential building. Any other building, commercial by definition. So these are the examples of the residential buildings. So if your projects are one of these, then you need to open up the residential provisions, not the commercial provisions. So to give you a small quiz. So there's a 5-story mixed-use building with 2 stories of retail store and 3 stories of apartments in Chicago. Is this considered as a residential building or a commercial building? Commercial building, because
5 stories.
yeah, it's a mixed use and it is more than 4 story. Easy. The second one, 3-story mixed use building with 1 story of retail and 2 stories of apartment in Bloomington. Commercial or residential building? Commercial? Commercial.
Excuse.
Mixed use residential building. It's a little tricky. See, it should be clear cut when you think commercial building and residential building, but sometimes it's not. And then third one, 5-story single family home. Commercial or residential? Commercial. Commercial? Commercial. Well, I think everybody's hung up to 5-story, but it is single family, so it's unusual to see 5-story single family home. But if there is one, then it is residential building because it is a single family house. So technically, if it's a 10-story single family house, it is a residential building. So you need to comply with the residential provision. The last one, 3-story hotel, commercial building, residential building. Commercial, because it's not a residential occupancy. It's a residency is permanent dwelling. So even though it's only a 3-story, it's a commercial building. So I'm glad we went over this because, as I said, at first I thought it's easy and simple, but sometimes it's not. So this is just to show you the history of the energy code improvement. So it's kind of hard to see, but so top part is residential, and the bottom is commercial. And this x-axis is the year, so it starts from 1975 all the way to 2018. And then this is a 0 and go up to 100, and 0 go up to 100 for commercial. So y-axis is a normative energy use. So what it is, this is a research done by DOE. So if we say that if the building that is complied to 1975 energy code for residential and commercial, let's say the energy use is 100. What about the next version of code? Oh, it's 90, which is 1986. So the model code, the energy consumption, if you comply with the current model code, the energy consumption of the building is actually kind of reduced by half. Right now it's like a 53 compared to 100 in 1975. So that's a good news. But then bad news is that by 2030, we say we're going to reduce by 0. We're going to go for net 0. So we have all the way down to 0 in pretty soon. So that's a bad side of story, but good side of story is that we've been working hard, and it's getting recently, tougher and tougher to cut more energy because all the low-hanging fruit and easy stuff are done. Now it's time to do more creative stuff and more complicated stuff maybe to reduce energy consumption of the residential and commercial buildings. So 2018 ICC. So I know some of you are probably a little disappointed that we didn't hand out the 2018 code books, but unfortunately our funding doesn't cover the books for everybody. But good news is that if you go to ICC website, or if you come to our website and we have a link, so there's a web version of 2018 ICC. So you can scroll down and you can do search. I like it when I want to, search for some keyword. That's very convenient. So, but you cannot print. You can only look at, on the computer. So at least there's a resource for this. So a little bit of like highlights on changes for commercial provisions of 2018 Iecc. So if you remember the graph, the energy consumption actually is almost the same. So in terms of commercial provision, it's about like a 2 to 5% improvement compared to the previous version, which is 2015. And then mechanical section, I don't know about you, but Iecc is, I think, personally better than ASHRAE 90.1 in terms of complexity, but still it is very confusing and complicated. Mechanical section, what they did mostly is reorganize the section. So there are not many like actual changes, but they reorganize so it's easier for us to find requirement for one system or one equipment. So the section numbers kind of moved around. And then, as I mentioned before, there are 2 additional efficiency package options if you follow the prescriptive path. That's enhanced envelope performance or reduce air infiltration. And then there are some like a language definition admin type of changes. And one change that I want to point out is that when Iecc was describing the function of the control, lighting control or HVAC control, they used to say, oh, this should be capable of this. But then, be capable of doing things and then actually doing it, actually 2 different things. So they changed the language to be configured, meaning that it needs to be programmed that way and it needs to be working that way. And then there's a new appendix in 2018 Iecc. It's called Solar Ready Zone. So it's not requirement. It's not part of requirement. It's appendix for you if you need a guidance on future solar projects. So it's an appendix. And residential provisions, this was included in 2013. But for the commercial, this is new, so they just added this to the commercial section. And then we, because ASHRAE 90.1 2016 is a compliance path under 2018 Iecc, we're not going to talk about it in detail, but it's a big change. One is that if you decide to follow the ASHRAE path, the climate zone has changed. So in Illinois, there are 6 counties listed here. They used to be 5A, now they're 4A. But remember, this is only for the ASHRAE 90.1. So if you are following commercial provisions of Iecc, climate zone hasn't changed. So in a way, 2018 Iecc and 2016 90.1 is 2 different climate zone map for these 6 counties. So if your project happened to be in these counties and you are thinking about going Iecc or ASHRAE, make sure that climate zone for the ASHRAE has changed. It's not the same as Iecc. And some admin or language changes in commercial provisions. So one thing I want to emphasize is that documents needs to be provided to the owner within 90 days of certificate of occupancy. That's written in the Iecc 2018. And also training for maintenance should be provided for commercial. So that is requirement. But practically, it is difficult to enforce because code officials, after certificate of occupancy, they hardly go back to the project and enforce it. But as a designer, architect and engineer, I think this is something that you need to make sure by code, by law, you are supposed to provide these documents to the owner and provide the training.
Is there a definition of what the compliance documents are? What's acceptable?
I think it is written in the code book, so in the break time, if you come back here, and then let's look at it together. And then inspection. It used to say construction work shall remain accessible and exposed, and now it's visible and accessible. I think the intent is the same. They just want to make sure that this is, it actually visible and this is actually accessible. And then another small language change. There's a thermal envelope inspection. It used to say framing and roughen inspection, and now it says thermal envelope inspection. So I take it this is more like a comprehensive inspection, not just framing and roughen, but you need to make sure that all the air barrier or vapor barrier, everything, the insulation, no thermal bridging, so there's an integrity in the whole thermal envelope. And then some definition change. Air barrier, it used to not say continuous manner, but they added this to make sure. This is what you're supposed to be doing, but they just added this to make sure that it is clear, loud and clear. And then alteration, it used to say, the projects that, kind of you change occupancy or, move, other than repair, it's alteration. But it used to say it requires a permit, but now that language is gone. So we don't know exactly what was the intent, but if I must guess, I guess even though there's no permit, you need to follow the energy code. That is my interpretation, but yeah. And then another big change, code official. Do we have code officials here today? No, none. There were 2 signed up. They didn't come. All right, so code official definition is approved before 2015. It says approved by the code official as a result of investigation and tests, things like this. But now, 2018 ICC, now it simply says approved means acceptable to the code official. So be good to your code official. If he says yes, then it is approved. So they have more responsibility and authority on what is approved and what is not approved. Because in reality, it's not all clear cut. There are confusing stories, and they're practically you cannot really do that. And if your code official look at your document and understand the situation, and if they agree that you actually did your best to try to meet the intention of the code, they might say approved, then you might be good. And this is a residential, the same definition changed. One different change here is air impermeable insulation. There's a definition added to the residential section. The insulation that functions as an air barrier material, that's air impermeable insulation. So how are we doing? So it's about 2. So I think we will go over a little bit of commercial, and then we'll take a break at 2:30. Does that sound good? Thanks.
So looking at the commercial, most of you guys are interested in the commercial side of things. But I will call out for some of these slides where I have black text up in the left corner. This is not a change, but it's something that we wanted to call out as a very important factor. So this is a question that we frequently get, is looking at, can I do this without complying with the thermal envelope provisions, and can I get away from some of the insulation values? And we point back to this and say, well, you might, if you can qualify as a low energy building or portion thereof. This gives the definition under 1 watt per square foot. This is kind of, have any of you been doing much in the way of passive house construction or design, or familiar with passive house A couple more for passive, at least familiar with it. This is getting down to about that level that they look at. I believe Passive House looks at under 3.2 BTUs per square foot, and this is 3.4. This is something that, if we're going to get to net zero, this is something that is going to have to become much more common practice rather than the exception to the rule. But if you're under this threshold, that simplifies things a fair bit. So, looking at it, so here's a question that came in is, how does it apply to buildings without heating? There again, with the IECC, it notes that if you're low energy, you don't have to comply with the thermal envelope provisions, but the rest of the code still does apply. So you still have to have good lighting and good HVAC systems. However, we do note that if you start this as a low energy building, say I'm going to build a building shell, but I'm not going to put any air conditioning or heating in it, particularly warehouses and things like that, where one firm is going to build it and then they're going to rent it out as space to others. So they're not going to condition it when they do the construction. Say, well, that can be fine, but when your tenant moves in, if they want to condition that space, going back and complying with that thermal envelope provision, if you didn't when you did construction, that can be very costly and expensive to do. Particularly if they say, I want a heated slab, because as we'll touch on in a moment, you now have to insulate under that slab. So you're going to have to rip the whole slab out in order to do it. This was another one. We are going for a net zero building. Do I have to comply with energy code? Again, we can point back to the low energy building. It just seems it seemed like a strange question to me, and you guys might agree or disagree, but if I'm going for a net zero building, then saying, do I have to meet the minimum standard? That was a little bit weird, but so this goes back to the heated slab that we talked about. So now in the 2018 version, if you have a heated slab, you have to insulate under it a minimum of R5. So typically probably 1 inch of foam underneath that slab.
Now, does that mean just if you have if the building is conditioned with heat in there, or if you actually have?
If you are providing heat using the slab, so that's probably going to be a radiant slab, not just a slab in a heated building, but you're actually putting the heat directly into the slab. There again, they say a minimum of R5. That's 1 inch of foam. Any ideas what it might cost to put a 2-inch piece of foam down there instead of a 1-inch piece? And now you're getting into comfort and saying, can I build a better building that's going to be more comfortable? Yes, I have gone beyond code to do it, but this may be one of those where if you're doing a comm check and you may want to trade something, I'd much rather provide a more comfortable building using some of that. So, daylit zones, this is something that they have kind of split up. It used to just be daylit zones. Now they talk about side-lit zones and top-lit zones, looking at them as independent things. So this image here is looking at a top-lit zone, and how do we determine what actually is in the top-lit zone? And these images in the code book are also in the online version, which is very helpful. So you can actually help determine that. But so throughout the code, they do talk about these independent of one another. So depending on whether it's in a top-lit zone, a side-lit zone, or both, will determine some of this. So here's something where how it may appear on a drawing as far as identifying, and this is required in the documentation, is you have to identify your top lit and day lit zones on the floor plans. So in this, we've got some windows here. I don't have any skylights in this building, so I don't have any top lit zones in the core of the building. But here you can see the side lit zones coming in, and that depending on if I'm over the wattage threshold, I may have to install daylighting controls in here. So, air sealing, I think it's probably something where we've kind of understood practically that air sealing has to be able to be maintained for the life of the building, not just the day I put it in. And so understanding that the air sealing has to be able to allow for the expansion, contraction, shifting, vibrations of the building without cracking and defeating. You know, I can use drywall with some mud on it to provide air sealing. However, when you do, you know, over the life of that building, as cracks develop, your air barrier is failing. And that can cause you some problems going forward in your building. Again, trying to look at these buildings as, you know, from a lifetime perspective. We don't want to build buildings that are only going to last and stand for 10 years. You know, how many buildings out there do we see where they were built 10 years ago and they're failing? And then you look at several buildings out there that are built 50, 70, 80, over 100 years old, and they're still standing and they're still in good shape. And so trying to take that into account and say, how do I make the building withstand the forces that it's going to see over its lifespan, and make buildings that will stand the test of time. So, looking at equipment efficiency, heating, you know, throughout these, technology continues its march forward. You know, minimum efficiency, the fact that minimum efficiency is still 80%. I mean, that's still the minimum, but we've now raised it from 78 up to 80. So we're gaining a little bit at a time. You know, again, going back to our net zero goal, it's going to be hard taking some of these smaller bites. Looking at boilers and controls therein. Up here, how many of you deal with a lot of boiler systems in this region? A couple? Few? Okay. It's not very common down by where I live, but I realize up here it's probably a little more common. So doing away with pilot lights, I think sometimes with some of these, the code is catching up to what manufacturers have been offering. And so, you know, things like a standing pilot light, I'm sure there's still equipment out there that offers it, but it's probably going away. Hot water reset temperatures built into a boiler. This is probably a little more something that may have to be more specified. Heat rejection closed loop systems using cooling towers. They're now delving a little bit more into that and the controls therein. So looking at how am I going to bypass this in the winter so that I'm not unintentionally rejecting heat outside in the middle of winter when I'm trying to heat the building. So having some of this in place, you know, bypassing and shutting off the pump when I don't want to get the water outside to throw away the heat. So VFDs continue to expand, price continues to fall, which makes these more and more economical in more and more locations. So now it's down to 2 horsepower and larger. Now if you have a full DDC controls, you may be able to use something a little larger, upwards of 5 to 7.5 horse. You may still not have to have the VFD. But it talks specifically in the code book about where those are. heating and air conditioning, and in particular reheat, are trying to reduce how much reheat we're having to do for buildings. And so the code is continuing to push forward as far as the turn down, going from 30% or 3-to-1 turn down to 20% or 5-to-1 turn down. Because when I'm down here in this orange triangle, I'm now paying to move the air, I'm paying to cool the air, and I'm paying to heat the air back up, to put it back in the room. So I'm now paying 3 times to not really end up actually accomplishing what I need to. So, yes, I understand that humidity control is important, because without humidity control, and we cause mold, mold is the bane of a building's existence. If it can't dry, it will die. But trying to minimize the amount of energy we spend to keep that done. So, code's now talking a little bit more about parallel flow VAVs, and trying to, again, minimize where I'm using that heat to try to minimize that reheating valve and minimize the reheat. A lot more controls are now mandatory for ventilation systems. Another area that we hear several questions about, particularly up in this region, is parking garages. When you have fully enclosed parking garages, you are now getting into ventilation controls and making sure that you have demand controlled ventilation on there, along with frequently heat recovery. Because if you're going to be operating over 8,000 hours a year, you're now into heat recovery for your exhaust systems. So there's a lot more demand controlled ventilation, particularly kitchens is another place we're seeing it more and more, and also guest rooms. They've now reduced the number of guest rooms you need before you have to qualify for this, and system sizes, and getting better dampers. It's now requiring Class 1 low leakage dampers for outside air dampers and exhaust dampers. So that's something that continues to progress forward. Also have more heating controls for ventilation systems, trying to reduce, or again, we don't want to throw away heat that we've generated unless we have to. And also trying to provide a little more guidance. Another one that's in there is vestibule heating. They are now providing better guidance as far as how to do that. The code is now talking about that vestibules are to be tempered spaces. They are not trying to provide full building heat to them. I believe it now calls for 60 degrees to be the setting for vestibules and no higher, at least for heating. So, this is one place where the energy code has gotten a little more relaxed, and that is for if you have ventilation operating over 8,000 hours a year, there's now some minimal amount of exhaust air that they now allow. Before, the limit used to be 0. So if you had an exhaust system that had 5 CFM of air that operated continuously, you had to do heat recovery for those 5 CFM. So this is one that's like, when you say you need to do it for 10 CFM, that's getting problematic. So this does give a little bit. There again, not a whole lot. I mean, even on the top end, you're still only talking 200 CFM as your threshold. So it's still very tight, but at least it gives you something. How many of you have stayed in a hotel that you have seen these at before? Just a couple? I was thinking this wasn't too common, but this is now requiring automatic HVAC controls if you have 50 guest rooms or more. And this is one way to do it, through the key card switch. They no longer allow the captive keyed switch for it. So it can be done via key card switch, occupancy sensor, or your hotel management software is also capable. One method to comply for this as well. This is another one where they've given a little better guidance as far as this pressure drop allowance for your HVAC calculations. It was a little less clear as far as, it's now for each air stream they provide that allowance. Before that was a little more murky. Motor nameplates, this is something else that goes on building prints. If it's less than 1 horsepower, it doesn't have to go on the building prints, so your fractional horse motors, but anything 1 horse and larger needs to be on those building prints. So, and again, part of this is, if I try to, if I go to replace something, we've all, I'm sure, experienced that, where you go to try to read the nameplate of some of the older equipment, and it's kind of worn away. And so you're trying to have to figure out, okay, what are the specs of this motor? So having that on the building prints is helpful just in case. Of course, then you have to be able to locate your building prints. Also providing further guidance as far as heat rejection and fan controls. So for your cooling towers and the like, providing guidance as far as actually varying the fan speed based on what your temperatures are. And again, going back to that VFD of 2 horse and larger, this is probably going to be most things. Refrigeration equipment, they're increasing the efficiency. And something else that's, they also call out that for walk-in coolers, there's a new efficiency standard that's going to take effect in 2020. So this is a mid-cycle change. So it's already in the 2018 book that takes effect January 1 of 2020, which is also a little complicated because here in the state of Illinois, the 2018 code becomes effective March 1st, 2019, and now you have another code rule that's going to take effect January 1 of 2020. So 9 months after the code takes effect, a new rule comes into place. So that is on walk-in refrigeration. So that's something I do want to call out to be aware of, is there is that extra little twist in there. Yes?
Does that take into consideration existing walk-in coolers?
This, the Iecc covers, it covers any new construction and renovations and alterations. So if you have a walk-in cooler that was fine when it was installed, as long as you don't touch it, it's fine. You can continue to operate it. Now, so something like the walk-in cooler, I believe it's on the door, is that 2020 rule that comes into effect. So if you go to replace the door, then you need the new door to meet the new requirement. But the existing one is fine. The code does not require you to alter something that you're not already going to work on. So it's when you're, and again, trying to identify when is it going to be the cheapest to make the improvement is when you're going to already make an alteration to it. So similarly, it talks about in there, in the code, like insulating a wall. If you open up and expose the cavity, you now need to insulate the wall, which kind of is somewhat logical in that that's going to be the cheapest time is when you already can see the cavity. It's not going to add a substantial expense to insulate it.
What if you're only doing a section?
And that's where you do get into some of these where it's like, okay, I'm going to, if I'm going to open up, this half of the wall, with the code, you have to insulate that when you expose it. So you are going to end up with only half the wall insulated, which is it is not ideal. I will give you that one. But presumably, at some point in the future, you're going to hopefully open the other half of the wall, at which point you would insulate that. But what it does is it does not require you to build out that wall. You only have to fill the cavity as it stands. So you may not be able to get the full R20 insulation in that wall that it might call for, but as long as you have filled the cavity with the insulation that fits in it, you're done. So that may be an R15 that you were able to put in that 2x4 wall, and you couldn't get to the R25. But R15 is what fit, and you fit it. So you did what you could without having to alter the structure. Yes?
Does that include changing different materials? I mean, with closed cell spray foam, you get to R25. Are you mandated?
No, it does not mandate that you have to use any specific type. It only calls out that the cavity must be filled. So, most of your insulation is probably going to be R3, 3.5 per inch. As long as you have filled the cavity, you're good. So now you may choose to go ahead and use closed cell spray foam and hit your R20 that you need, but there's nothing to require that. Yes?
The point there, if you did do spray foam, you got the R20 with like 2 inches, and you have another inch and a half 3, you still got to fill it.
Nope.
No.
You have met the code. You have met the requirement.
Well, I thought it was filling half.
That is an exception that allows you to not meet the requirement. Sorry, yes, there's an exception that you don't have to meet the requirement as long as you fill the cavity.
Okay.
So that's one of those little nuances, and that is in renovations and alterations. So new construction, you have to meet the requirement. So
If you retrofit it with foam, for example, you don't fill it, but you meet the requirements, you're good.
you're good. Yep. This is the one that I was talking about. So yeah, this is a specific one for 2020. Generally, the codes try not to do this, where they do a mid-cycle change like this. But part of this may be something where they've been working with the manufacturers, and the manufacturers say, I've got something in the works. I don't have it out yet, but I will have it to market by this time. That's generally when they will try to use this. And this is also another benefit of when you have that definition change of what is approved being acceptable to the code official. The energy code is one that gives the code official some leeway in saying, have you done what you can that is technically feasible? So for something like this, if it turns out that there is not a way to meet this standard for the door without tearing the entire walk-in out, your code official, it would not be uncommon for the code official to say, tearing out the entire walk-in cooler because the door isn't quite right is not logical and therefore not technically feasible. here. So I will do this slide, and then what do you say we'll take about a 15-minute break? So this HVAC construction, Sumi had talked about, there was a lot of reorganization in here. They've tried to consolidate a lot of this material together. The other reason they did this is all of these sections are mandatory. And so mandatory requires you to comply no matter whether you're using prescriptive or performance-based. You have to follow the mandatory provisions. So now I'm calling out that you have to duct seal unless the ducts are fully within the conditioned space inside the thermal envelope. So there is some ability there. And also piping insulation is becoming required. They call that out in the book. What questions, other questions we have to this point? All right. We'll take a break and come back at 20 till 3. All right. So we're coming back. Had a couple of questions out there that wanted to be asked after break.
About energy code.
Energy code, yes.
Specifically in Chicago, Chicago following 2015 International Energy Code, but they stay with that code. What happens when the state adopts 2018?
Okay.
Still stated that in the building code in Chicago.
Yeah, good question. And that was where this goes back to. There is an Illinois amendment that actually touches on this, and that is where they talk about above code programs in the state energy code. What it calls out is no jurisdiction can adopt anything that is less stringent for commercial. They cannot adopt anything less stringent than the state. So when the state moves to the 2018 version, that doesn't rule out any of the, it doesn't necessarily rule out any of the Chicago Energy Code. However, it must be any of the requirements must be at least as stringent as the 2018 code version. So there could be something such as the urban heat island things, because that is more stringent than even the 2018 version, that will still apply. So anything in the Chicago code that's less stringent than the 2018 version, the 2018 rule applies. There was another question. Another one? Okay. If you think of any more, that's always good. But yeah, that's sometimes. Fortunately, the Illinois amendments are fairly thin, so there's not too many of them. And similarly, I think because the energy codes have been catching up to where Chicago started, because Chicago Energy Code, I think, goes back to 2004, if I'm not mistaken, or 2006. So as the state code has caught up, I've seen the City of Chicago amendments actually shrink some because the code has finally caught up to where they started. For service hot water, how many of you are doing renewable or heat recovered for service hot water yet? Okay, not too much. It's a little chilly up here for some of it. But it used to just say solar for heat recovered energy. It now covers all renewables. So whether that's wind, heat pumps probably also qualify under that as well. So for site recovered. This was something that they had put in for hot water heaters some time back as far as you have to put heat traps in. Here's an image of a physical heat trap. Normally it's just seen as a device that goes in the threaded connections. But they've now brought it up so that hot water storage tanks also have to have heat traps in them. Because there's not a whole lot of difference other than is there a heat source going into the tank, which presumably if you have a storage tank, you have a heat source that's feeding that tank somehow. Pool covers are continuing to push this higher as far as when you have to have a pool cover for new pools. It now has to be 75% site recovered energy, whereas before it was only 70% site recovered. Service hot water heat or service water heating no longer have to do commissioning on the systems. Part of that is because they've called out in the code more specific as far as the controls of time and temperature, that you don't have to have a lot of complexity to the systems to make them work. Residential lighting, residential provisions for lighting, which is high efficiency lighting, is only for multifamily buildings in the state of Illinois. So if you are in the commercial provisions, the only time you're allowed to go over the residential for lighting provisions is in the event you're in multifamily. Otherwise, you have to use the commercial provisions. Are any of you doing much in the way of luminaire level lighting controls? Some. So this is where every fixture has an occupancy sensor and a daylight sensor built into it, which pluses and minuses to this, but instead of having to have centralized lighting controls, you can now do them at the luminaire level, where every fixture has its own sensor and responds to its own independent signal. So that can simplify things and make things much more expensive at the same time, depending on how you do it. But we do call out that it must contain both occupancy and daylighting controls in the fixture. So it can't be one or the other, it has to have both in order to qualify as luminaire level lighting controls. Occupancy sensors, this continues to be a growing area now for open plan offices, and there's even requirements as far as how big the zones can be. I believe it's 600 square feet per zone is what you're allowed for these open office areas.
So it's mandatory now?
It's now becoming required, yes.
Occupancy or vacancy sensors?
Good catch. Vacancy sensors. Sorry. Yes, that's another thing that they've moved towards is occupancy sensors are only in a handful of locations now. They require vacancy sensors for most applications. I believe occupancy sensors are restrooms, hallways, stairwells. I'm trying to think if there's any others that I might have missed. But yes, vacancy sensors are now the standard, which is a little strange when you go to the store to try to buy a vacancy sensor and they don't carry them, so you have to order them. So, but yes, not only for open offices, now lounges and break rooms, and warehouses, they now call out the storage area of a warehouse. Because you may be in a warehouse but not actually in the storage area. You're probably in an office area or a hallway or other things. So they've clarified that warehouse means the storage area. Time's getting shorter. Fortunately, more and more people are going to LEDs, which are less susceptible to problems upon switching. So reduce the time delay going from 30 minutes down to 20 minutes of vacancy before the system turns off. Something else I should call out, you may also see the numbers in the upper left-hand corner of these slides. That tells you the actual code section that this is referencing back to. So if you do run into a question or want to actually read the specific language, that references you back to what the actual code section is that we're talking about. Daylight responsive exception. This is one that I think is extremely helpful and can be very beneficial, and that is, if you meet this threshold, you don't have to have the daylight responsive controls for the building. And what this is you have to reduce the wattage by 40% of the area that is in the day lit zone, which sounds a little confusing. But for our example, if we have half of our total floor is in a day lit zone, either top lit or side lit, and if I am 20% lower than the total wattage budget for the building, I've met the threshold. So if I have a building that my total lighting budget is 100,000 watts, and I have half of the building is in the daylit zone, if I am at least 20% lower than 100,000 watts or 80,000 watts, if I am below that threshold, I don't need daylighting controls. Done. Yes? The daylit zone and side-lit zone, there is, and that goes back to some of the drawings earlier. They will say it is, I believe side-lit zone is head height of the window, flopped in, I think it's the width of the window plus 2 feet on either side, or until you hit the obstruction. That's a full height, 0.7 height wall. So yes, there's criteria as far as that they spell out. And top lit zone, that was one of the images shown earlier as far as 0.7 times the height of the, so. But yes, so for this, it has to be 40% of the percentage of the floor that is in the daylit zone. So that's why, because it is, I said it's 50% of the building, so it's 50% of 40%. Because 40% is my daylit zone area. So it gets a little...
How do you calculate a picture like this, where if you take the daylight zone and you lay it down, it's going to go past the mezzanine? So which floor does the daylight zone apply to?
You would have to end up looking at each. That is a really tough one. I'm like, okay, the upstairs is the easier one, but because I have an obstruction here, when I go to flop this in, this lower area could be a tricky one. That is a good question. Remind me to never use this picture again. But yeah, the head height for down here.
I think until you
Yeah, you would end up with an obstruction.
Right.
If you're flopping this in, that's a 45-degree angle, so it would presumably be 45 degrees off of this obstruction back.
I think you need to look at like a floor by floor.
Yeah,
So
that's
first floor, you see the top of the
yeah.
the
But
first
when you have the
floor,
head
I
height,
think
but
that's the head height, plot it until you hit the obstruction. Then second floor, you see it separately, and you take the head height of the second floor and you plot it.
But yeah, because coming off this at a 45-degree angle probably would not be as high as that flopped all the way in, I bet. So you'd end up with a truncated daylit zone on that first floor. It wouldn't be the full head height because of that obstruction of the floor. But yes, this is one that any suspicions why they say if you're below 40%, you don't have to do daylighting controls? Any suspicions as to how much daylighting control saves? About 35% by some studies. So they say, if you design your whole building better, I can simplify the building for you because you've given me the savings in a simpler way. Yeah. Can daylight controls be manual controls? The dimmer switch on the wall? No, unfortunately not. They have to be automatic daylight controls. So this is another top light example. Provided further guidance on rooftop monitors. So they're seeing a little more of this. Probably what we're seeing more of now is just straight skylights, but for those that use monitors, so the daylighting does not extend under that monitor. So this was one talked about earlier. Captive key switches are no longer allowed for sleeping units. But went over 3 different ways you can do it, and they are occupancy sensor, hotel management system, key card. There we go. Exterior lighting controls. Previously, you had to have daylight shutoffs or photocells or time switch controls. Starting with the 2018, you now need both. So this could be a single system that provides both time switch and photocell, or it could be 2 controls in series. The only requirement is you do have to have both. They now require that you turn off decorative lighting overnight during non-business hours. And I believe in the code, they do allow you to keep it on for an hour, 1 hour after closing. So people can see it as they leave. Yes?
What about for automobile dealerships?
Counts.
1 hour after they close?
Now that wouldn't probably qualify under decorative lighting. However, they would fit under this 30% turn back. So this could be you turn off 30% of the watts. It could be you put in dimming fixtures and just dim them back. So
decorative lighting in terms of, here, it is for facade and landscape lighting. That's what they call decorative lighting in terms of exterior lighting.
Yeah, the facade and landscape lighting is your decorative lighting. There is an exception for dwelling unit controlled fixtures. So the light on the balcony, that's not part of this. But yeah, this is also something that we are seeing because they are improving these codes as far as when you have to turn lights off after business and so on and so forth. We are seeing more municipalities adopting zoning rules to match this. Because it's one of those, you look at it and you say, okay, you do this as new construction, so I put in a new business. Well, they have to have all these controls and turn off their lighting, and the business next door doesn't. because they weren't part of it. So we are seeing some municipalities adopting this as more of a zoning issue and saying, this is good business practice to not light everything, till the wee hours of the dawn when no one's around anyway. Now there is exceptions for security lighting that is approved by the code official. So another way that we have seen this implemented is with this lighting setback is to say, okay, my building mounted lighting, dusk to dawn, my close-in parking lot lighting can be dusk to dawn, and the ones away from the building, we'll go ahead and turn those off because no one parked away from the building anyway. Track lighting. This is one that reduced for your lighting power calculations. What is your total connected power? For track lighting, it used to be 30 watts per linear foot of track. It's now down to 8 watts per foot for your calculation. We suspect that part of this is because of high efficiency lighting continuing. If you try to put 30 watts per foot on that track, you would have a whole lot of lights. Even with 8 watts per foot, you can still do a fair bit of lighting with that.
Is that just for offices or is that different with retail?
This is the commercial power calculation.
Across the board?
Yep. Now, this is the default value. If you have more connected power on that track, you have to use the higher value. But if you have a lower amount of actual track lighting, because in retail, yeah, you could have 30 watts per foot, because I got to showcase my product. But you have to use the higher of either the default value or the actual fixtures that are on that track. So that's another good thing to point out. Again, lighting continues to get more and more efficient, and so lighting power allowances continue to fall. Offices, not a big change here, a little bit lower. The big one is libraries. This is a big change for libraries. But you think about the more modern library, how much is a modern library looking more and more like an office? With all the computers and all the technology and you're trying to read and we get that. But this is probably why this one fell so much, is they're looking at saying it's looking more and more like an office and less about a giant stack of books. There are now a few more exceptions as far as what is in your exterior lighting power calculation. So again, we noted your security lights, and for safety, so your entrance and egress probably is likely to be an approved. Emergency lighting that's not on during normal operation. Exit signs have now been removed. Make sure you light your national flag.
That's for emergency? What's that for?
Well, your national flag. You just want to make sure that no one says, well, I would have lit it, but I ran out of power. I couldn't put the 100 watts on it. So, the key we want to point out is this is approved security lighting, which, going back to our definition of approved, code official has to say yes.
So what about lighting in the exterior of the building?
Facade, that is part of your exterior lighting calculation.
So if the building's closed, you have to turn it off? Like what about a campus that's kind of 24/7, but the building's not?
That goes back to your decorative lighting is part of the facade, so it must turn off 1 hour after closing, which I realize campuses don't really close, but some of that, and again, where you have general area general area lighting versus facade lighting. So you get into some of this, it's a little bit of a nuance. And as far as who your code official is that actually gets to say approved or disapproved is this for safety considerations? Because yes, on a campus, I need general area lighting for safety at 3 in the morning because I have students out at 4 in the morning. So there is some, on a university campus, you definitely get into some gray area here. So whether it's part of it or not. And again, part of that is looking at it, is the purpose of this to be decorative and I just want to light the side of the building? Or is it, I'm trying to provide this light for security purposes? So that's probably where you're going to get into, which category, do you need to turn it off or not? Is it purely decorative? Most places look at it, and in a college campus where you never actually close, well, when's 1 hour after never? So commonly what we've seen is after, places will say, once I get much past midnight or 1 a.m., I'm going to turn off my decorative lighting because there's no one around to appreciate it.
Does this section also go over night sky protection?
Night sky protection is not in the energy code. That is a local jurisdictional question. So, the energy code just basically tells you what your allowance is and how you choose to spend it is a personal decision. Again, similar to the interior power allowances, the exterior's falling a little bit more too. Yes?
The street light, the white features in swimming pools,
Mm-hmm.
do they qualify as, is it all the light of the white feature, or is it decorative, or is it safety, or, because I have a white feature that has a lot of light, so it has to be on safety.
And again, this goes back to, is this in your power calculation or not? As far as what you're allowed to use for exterior lighting. If it's for a water feature or a swimming pool, it's not part of your power calculation. We don't see too much of this around here, but I know City of New Orleans has a lot of this. But if you have natural gas lighting, no standing pilots. Again, March for Efficiency, transformers and motors. Transformers now have to be DOE 2016 efficiency or better. And motors have to be NEMA premium or better. Here again, some of this is, when they come out with standards, I feel like this is almost one that they're that the code is catching up to where the technology went. Because when DOE released their 2016, I think most manufacturers looked at it and just started making it. We don't need to, I don't need to carry an efficient version and an inefficient version unless someone's got some in the back stock somewhere. But yeah, so this is another one. We had talked earlier about the additional efficiency options. This is one of them as far as better building envelope. And so this is, are you at least 15% better than the minimum in the table? So if you are at least 15% better than the standard in the table, because again, this is prescriptive, is when these enhanced values come into play. So if I'm 15% better than the table, I can tick this box. I've got my enhanced envelope, and I'm good. I can also do it by air tightness. So air tightness, if I have air leaks, that means I probably have humidity leaks, which means I might have mold or higher chance of mold. So this is another option that they give you is you can test your building to check the air leakage. Commercial buildings are not required to do a pressure test if they use the table of materials for their construction. You can choose to do a pressure test and verify that your building doesn't leak, which I always think is a great option if you can convince people to do it. But they set the standard at 0.25 CFM at 75 pascals. So this is, it's a pretty tight building here. Now they also do have a provision that if you're over 250,000 square feet, you can test your building in sections, but the test must cover at least 25% of the building. So if you can break your building into four sections that are all exactly 25%, then you have the ability to pressure test your building in 4 sections. Or all at once, if you prefer.
Is that 0.25 CFM per square foot of enclosure area?
Per square foot of the envelope. So this is looking at how tight is the envelope. So it's not per square foot of floor area, it's actually the envelope surface area. Providing some guidance on electric vehicles. We are not putting the electric vehicles in the energy calculation because that's not part of the building, unless you want to. But yeah, so they're providing guidance because we're seeing more and more electric vehicles, and predictions are we will continue to see more. But we're not going to try to put those in the energy model. If you're doing on-site renewables, they're now limiting the credit that you can take at 5%. Because they're trying to prevent what you see in the picture here. I can build a net zero greenhouse if you give me enough solar panels. So saying, we want good building design. We want you to have the ability to do on-site renewables, but we want the focus to be on good building design first. So.
The previous slide
Sure.
about the 75 pascals in a very large building. I'm familiar with the PPI standards of 50 pascals.
Yep.
This is for a 1,000, 2,000 square foot building. It's a pretty good sized blower. My God, how big does the blower need to be for a 100,000 square foot building?
Commercial building pressure tests takes it takes some beefy equipment. For the commercial side, the residential side, yeah, we're trying to meet 50 pascals with your air leakage testing. You will do that with 1 fan. Commercial blower door testing, you can fit up to 3 fans per doorway. So if you have a double door, which is not uncommon, you can actually fit, you can have 6 of those fans, and they actually design equipment that ties it all together so it all works together as a single, or in conjunction with each other. Yeah, so a double door, you can fit up to 6 of those fans. And so you may end up, yeah, in large commercial buildings, you'll end up with several of these setups. I mean, it's not uncommon for large buildings where it'll take some good air. Yeah. And they even make, for some of this, they even make large fans that will actually back up to a loading dock bay and pretty well fill the loading loading dock bay for these major pressure tests. Right. O&Ms, the code is now put in that you have to provide O&M documentation to the customer. It also calls out things that need to be in there, and that is there needs to be a page that lists what the O&M is. You know, you need to change the belt on this. And then you have to, so you have to say, yes, you need to change the belt, and I have to tell you where in the O&M documentation that is. So it'll say, change the belt, book, you know, book 81, section 3. So you can go to that to find out what you need to know about that belt. So a lot of times the O&Ms don't look quite even that nice. But looking at it and saying, again, going back to, we want these buildings to last. Well, how can you get a building to last if you can't maintain it? And how are you supposed to maintain it if you don't know how to maintain it? So at least if you have a simple, here's what the O&M, or here's what the maintenance needs to be for this, and here's where you go get more information on it. It's really hard to maintain a building without that, other than 30 years of experience on that building. Commissioning, and this is now have to do functional performance testing as part of commissioning, and that has to be documented and provided to the code official as far as here's what the functional performance testing for the commissioning is going to entail for this building. So the code official gets to see what you're going to do. Alterations. This is one that we get frequently in trying to figure out how do you meet code for alterations, because most of our building stock is existing. So one option that they do is for a change in space conditioning. This is one that we see commonly is garages. People have a garage, they want to turn it into living space. Well, a garage was not intended to be living space, and so wasn't originally conditioned. So now, if I want to condition it, well, now I have a change in space conditions. So now how do I meet the code for that? One way they give you is you can do a performance path for it. And if you can show that the consumption after the change will not be 110% of the code allowed, and that's not just the performance for the garage, but that's the whole building. So if it's 110%, then you're allowed. And we're done. That was the other one that came up, was garages. For garages, what they typically have run into is if you change, you now have to insulate the foundation of the garage. Trying to do that to a garage after it's built, a little bit of a problem. And so what the code calls out for is R10 insulation on the foundation. So what we have talked about is, and we've had several code officials that say, yeah, that works, is instead of insulating the foundation to an R10, insulate the entire top of the slab to an R10. And then protect it for fire codes. Because that allows you to get at least as good performance as the code required insulate the foundation to R10, because you have provided R10 across the entire surface, and you have thermally broken it, and looked at it and said, from an energy standpoint, that is at least as good as the code. It's not ideal, but given where we started from, and if we have a garage that we're going to heat, that's not conditioned space, you have to meet the envelope requirements of the code. Illinois has an amendment that is very useful. While you do have to meet the thermal envelope insulation requirements, you don't have to pressure test it. You don't have to do an air leakage test on a garage. So that is an Illinois amendment that makes it a little more useful. Because what's the likelihood that you're going to get that door to seal and hold at 50 pascals? All that seal around that door? That's going to be tough. So, excess fenestration. If you end up with an existing building, yes?
How would you do major occupancy changes? The major change, which increases energy consumption.
Can you give an example of the change?
The research lab.
Okay. That is likely to be either you're dealing with process loads, but it is with alterations. So you didn't go from unconditioned to conditioned. So you don't trigger that provision of the code. But with renovations and alterations, whatever you touch must meet the new standard. So in that case, you'd be hard pressed to meet the 110% with that. But this 110%, is if you are changing from non-conditioned to conditioned. That's what triggers this. So if you just change the space type, that's not part of this. But yeah, so if you change from offices to research labs, you're probably going to touch HVAC equipment. So whatever your new HVAC equipment is, needs to meet the code standards and the lighting and so on and so forth. Whatever you touch, but if you change the space and you don't touch the lighting, then the code doesn't say you have to go and touch the lighting to bring the lighting up to code. At least the energy code doesn't. Yes?
So a similar question, if example is, if I am in the West Loop, I am changing a meat packing former warehouse into a commercial building. That is definitely going to be conditioned now, it was not conditioned before. So that has to cannot exceed that 10%.
That's when you trigger, that's when you trigger either the 110% or the thermal envelope has to comply with the new code. You have to bring the thermal envelope up to the current code. This allows you a way that you're allowed to be 10% over code because it's 110% of the code. Energy consumption.
And the code would be, the description would be a new building equivalent.
New building equivalent to built to code. This is why we always caution when we get the warehouse question of, well, do I have to comply with the thermal envelope if I'm not going to condition it? You don't have to, but if you change it, that can be costly. So it's much better to start with a good envelope first. But in that example where, yeah, you're changing from a warehouse to office or residential, you've now moved from non-conditioned to conditioned, and you're no longer a low-energy building.
What was it previous? What was it that this is a new section in the code, or was it previous that before it was just?
Before you didn't have a performance option. You had to bring it to code.
Right. Okay.
This allows you some flexibility. If you're nearly there, you can show it via performance that I am not perfect to code, but I am close. The code allows that now, where before you had to bring it up to code and that was end of story. So with this provision, it can be one of those where if your building was pretty good when it was built, say that warehouse, I built it to the 2015 code version. We'll say I built it to the 2015 code version of a conditioned space, even though it was non-conditioned. I'm going to condition it in 2019. Well, now you'd have to bring it, previously you'd have to bring it up to the 2018 standard. Now you can look at it and say, the 2015 version that I built it to is close enough that it'll let it slide in. So it's one of those, I tried but I missed, but I'm close. Some of this that we end up seeing in a lot of repurposed facilities is excess fenestration. There is code restrictions as far as how much fenestration you're allowed to have. If you have a building that already has excess fenestration, you don't have to change it. But you cannot increase the fenestration area. So as long as the window opening was already there and you go to replace the window and the new window meets the code standard, as long as you didn't increase the area, you're still fine. So before you would have had to say, well, I was over, so I got to decrease my window area. I can't put a new window in because I'm already over, so I'd have to break up the windows before I could start to replace them. Doesn't make a lot of sense.
Looks like with one door that increases the fenestration. Second from the left.
This one over here?
The other door.
This one?
Yeah.
May have been existing. Or maybe not.
Okay.
Another one of these, not a perfect picture. But definitely excess fenestration.
Yes.
Can you keep the existing amount? If you were to brick up one window, could you add another window? As long as you don't go over what's existing.
I do not. I don't think so. But I'm not going to say positive. I'm definitely not sure on that. This is part of the reason why we also recommend that you email us questions, because for some of these where it's like, if I'm on the phone, it's like, I'm going to have to get back to you anyway, because the first thing that I do, anytime we get a question, the first thing I do is I'm pulling out my code book to figure out what exactly applies, which, when you send us an email, that's a good question, very good, good segue. Please let me know if you're in a residential or a commercial building, because it has frequently occurred that I'll read through it and then try to figure out which section of the book do I need to be in. Am I in the C section or the R section? And it has happened where I'll give an answer and then they'll come back and say, oh, this is a residential. Okay, I'll give you a different answer then. I'll look up the answer for that. So that is very helpful if you can tell us if you're in a residential or a commercial building. So, other stuff for commercial. Okay. Now residential provisions may still apply inside commercial buildings. again, going back to our definition of residential, to think of residential occupancies that are in commercial buildings. So we're in a high-rise building, but I have residential occupancies inside the building. So I won't go over too much of this.
Dormitories covered?
Dormitories is a form of a residential occupancy. So this talks a little bit about what's required to be posted on the documents for construction documents. When inspections occur, again, being that we're here at University of Illinois at Chicago, a lot of this probably isn't going to apply terribly much because you're probably in a commercial building, and so these inspections would be in the commercial section. But we've underlined for residential inspections what the code inspectors are looking at. And this is straight out of the code as far as what to look for. What's your insulation? What's your thickness? Do you have it there? Is it protected? Or is it all torn up already by contractors? Mechanical rough-ins, and then final inspection for occupancy. For homes, this is just for residential buildings, not necessarily occupancies. I need a label that tells you what the major components are. And why might this be important? If I change one of these components and use something that's a worse version, what might that do to my building? Comfort? Or heating and air conditioner? I need to know where this building started its life, so because that little label that's on the window that tells me how good of a window it is, long since disappeared. So if I have this label somewhere, typically located at the electrical panel, because it's easy to find there, I know if I need a replacement window, I know how good of a window I may want to replace it with. I may want to still get a better window than this, but at least I know I don't want to get worse than that. The new piece in log homes, they have their own building standard. They're not part of the energy code. Rarely do we find that. Windows are getting a little bit better. U values decreasing slightly. Still not a whole lot of change here. Allowance for reduced insulation. So up here where we need, I think, R49, you're allowed to have only an R38 if it goes the full height, even over the top plate. You can get away with a slightly reduced amount of insulation if you get it all the way to the end. Because right here at the end is where I'm going to have my thermal bridge. So if I reduce it there, then I have to add more insulation back here to make up for that deficiency. Sunrooms, people love their sunrooms. They have specific requirements for sunrooms. Again, noting thermal isolation between conditioned and non-conditioned space. So if you are isolated from the fully conditioned space, then you can get away with a little bit less insulation for a sunroom. If they're not isolated, full insulation. More fenestration. Can we put a fireplace in a sunroom? Does it count for low energy? It's a heating source, fireplace counts. So if you want to put a fireplace in your sunroom, it is now conditioned. The question was regarding a decorative, I believe it was decorative only. Like, can you find anywhere in the documentation that says it's decorative only and provides no heat? Then it's not decorative only. This was our this was our heated garage. So again, there's an Illinois amendment here that we call out for garages. So if you're thermally isolated, which if you're a garage, I want to make sure at the very least, I'm isolated from an air standpoint, even if not a thermal isolation. Roof insulation. Now, if you're dealing in a residential building, not residential occupancies, but residential building, they do not have a separate flat roof item in the table. So you still have to do R49, even if you're on a flat roof in a residential building. Now, there's a caveat to this for renovations. Renovations, it is, again, goes back to what is technically feasible given the existing conditions. Have you reached the maximum you can given the conditions? So even if you don't meet the 49, did I build it up as high as I could go? Then they'll generally look at it and say, you did all you could with what you had. Sorry, someone 100 years ago ended up messing you over. Right. So yes, this technically infeasible comes into play frequently in renovations. Because what can you do with what you have? Moisture control. This is something that comes up is with that heated slab and that insulation, protecting that insulation from moisture. That is not an energy code thing. It goes over to its building code issue. So for the protection of that insulation from vapor, you go over the building codes to find that section. So it's in the International Residential Code and International Building Code is where you find those moisture provisions. Bless you. We like to call this table out. 95% of all errors that we find in residential construction as far as mold are because something in this table went awry. This covers air barriers and insulation. Almost all mold is caused by an error in this table. Ductwork testing, heat recovery and energy recovery. You don't have to do the test, the duct leakage testing on the ventilation air, because that's outside air. If you do if you are going through energy model and performance testing, or not performance testing, but a performance path, the code now provides some guidance as far as how do you know, or how to treat fully buried ducts. So this is ductwork that has the full insulation value over the top of that duct. And it also has provisions for determining if you qualify as fully buried. Now, one of the requirements is the duct leakage test has to be lower than normal. I believe it's 3 CFM per 100 square feet for normal duct. If you want to qualify as fully buried, then it has to be below 1.5 CFM per 100 square feet. So,
It's fully buried from the top of the duct, so R49
from the top of the duct up. Yeah. So, This calls out, there's a couple of different provisions in the code where they talk about some different aspects. One is that we touched on earlier, that that parallel fan powered box it does not require you to install that equipment. This is another one, was drain water heat recovery. There's nothing in the code that requires that you install this. But if you do, it must meet the provisions of the code. This one they talk about the pressure drop within the unit itself must meet a standard. So, is anyone doing drain water heat recovery for projects yet? No one yet? Okay. I'll be interested to see how this one takes off, because I love the concept. As far as application, it can be tricky. Yeah. Well, with PVC, what this actually, it's the drain water heat recovery is basically an entire unit that you just put the Firmco couplings on the end and just transition from the PVC into the drain water heat recovery unit and then back out into your PVC.
So it's like a copper heat exchanger?
Copper water-to-water heat exchanger. So it's just a coil of wire wrapped, or a coil of pipe wrapped around the center pipe.
Preheating your domestic water.
Preheating your water going back to the showers. So that's one that I love the concept of it, but as far as yeah, well, there is some pressure drop, and I think that may be part of the reason why it was added into the code, is it has to make sure that you're not causing excessive pressure drop. Because, I mean, the inside is hollow, so you don't have any pressure issues on the drain side, but that spiral going through, yeah. So
I just use a small pump, and the pump uses more energy than you recover.
Yeah.
That's useful.
Yeah. Well, this is just yeah. Well, this is just using the city water pressure to drive it right through, and saying, because yeah, you're just trying to preheat your domestic cold water to basically temper the cold water with the hot water or with the warm water that's going down the drain. So, you know, if I can pick up, 50 to 60%. 50 to 60% of the BTUs, I think, is what it recovers. That's a fair bit. So, depends on how many showers you have,
Yeah.
if that makes sense.
For your time in the shower, and that's it.
Yeah. Well, if you have only one person, but if you've got either people that like to take long showers, or you have, I don't know,
2 flats or 3 flats.
Yeah. Or, I mean, I'm even thinking dormitories
Yeah, that would be great.
with gang showers where you got, hundreds of people using a handful of showers. Might not be a bad thing to look at and see. So, yeah, it depends on how much shower do you have. So, they now address fan efficiency for energy recovery and heat recovery ventilators. I almost feel like this is a premium product, and I'm not sure that this impacts anything. There it is. How to define if your duct is fully in the conditioned space. So, obviously, if it's inside the air barrier, you're inside the conditioned space. But, and here's where the buried in the ceiling, this is your fully buried ductwork. Here's your checklist to see, does it qualify or not. So again, very low leakage. The air handler has to be inside the thermal envelope too. So that's one, if you end up where your air handler's up in the attic, you're done. Unless your insulation is on the roof rafters. Equipment sizing is now required. Pool cover, similar to commercial, up to 75% now. High efficiency lighting. Now this is a provision where there is also an Illinois amendment. And that is they've redefined what high efficiency lighting is. For the state of Illinois, it is proposed to be 55 lumens per watt for a fixture and 65 lumens per watt for a bulb or a lamp. Yeah, it's 55 lumens per watt for a fixture and 65 for a lamp or bulb.
The way that this will be rated on lighting fixtures, it's called efficacy, that not efficiency. Just when you're looking at product data,
Yes.
that lumens per watt rating will be called
Efficacy. Yep. Yeah. And there again, going back to, there's another one, I mean, LEDs are now 80 plus,
even more than that.
100, 125. I mean, some of them are over 200 now. But
Not the call.
and so you start to look at it and you say, well, okay, I got to be above 55 or 65. Technology has now pushed the floor to like 80 or better. You know, okay. However, and this is part of the reason why the track lighting changed, low voltage lighting now counts. There's no more exception for it. So when you say, do I have high efficacy lighting, it's got to be 90% of all the installed fixtures. And I have to make sure I count the low voltage, because this was where we were running into a lot of challenges. Was people would just put in low voltage track lighting, put in all those MR16s everywhere. It's like, well, it's low voltage, so it doesn't count. No. So they have since removed the low voltage exception. Ventilation now has to be in the energy model for residential, if you're going that way. If you are doing modeling, they now allow you to do sampling. So I've got two apartments that are next door to each other. They're identical apartments. They face the same way. They're the same. I don't have to run two separate energy models. I can just run one and say, applies to both units. So, for larger projects, this will come in handy. And if I'm going to include ventilation in my energy model, the reference that I'm going to compare it against also includes it now. So we added it to both sides of the equation. This is one of the bigger ones, was the energy rating. Actually, that's the next slide. But yeah, here again, similar to commercial, we are going to exclude our electric vehicles. ICC is also teamed up with ResNet, so the standard is now an ICC standard, not just a ResNet standard. Here's a big change. They're trying to encourage use of the ResNet or HERS rating system. They've substantially increased the score that you are allowed to get by 10 points. So that's quite a jump. So what this would actually do is, if you go the HERS route, that may make your building a little, it could potentially make it a little worse than code and still qualify. Possibly. But in order to get a HERS rating, that score has to be registered into the national database that you can now look up. So when you go to sell that house, that score is known, or at least searchable. Personally, as a future homeowner, I really wish this score was posted on every sign to say, okay, the house may not be pretty from the road, but I'm looking forward to the lower energy bills. So, change in softwares happens over time. Fenestration for residential. You can use a weighted average. So if you have a building that's not quite as good, or a nice decorative stained glass window that wouldn't necessarily meet energy code, you can use a weighted average to say, I like that window that's not as good, and I'm going to use better windows over here to make up for it. A little bit of a trade-off. Insulation. So here's where the code does call out, it has to be at least an R3 that you use per inch, which pretty much almost every insulation's that, at least, or better. So, again, provided that the cavities are filled, you can have a lower R value as long as you fill it, or you can meet the R value and not fill it. Either way. Yes?
Do the same occupancy, you don't change that, but you don't touch the exterior, you can just let it be as is, right?
Correct. If I didn't expose the wall, I don't have to touch it.
But if you change the occupancy and you didn't expose the wall, would you still have to break up? Because you didn't touch it.
The changing occupancy doesn't trigger. It is either you expose the wall or if you changed from non-conditioned to conditioned. So those would be the two things. So yeah, if I go from a single family home to a duplex or to, that won't trigger anything. But if I open the wall, then I might as well insulate it while I'm there. Air leakage continues to get a little bit tighter. We're now down, the anticipation is we're going to be down to 4 air changes per hour from 5 now. It is anticipated that this amendment, as far as how many air changes per hour, will go away in the next code cycle. Because the model code has it at 3. So we'll now have gone from 5 to 4 to 3. So when they changed and went to 3, it was 7, which is why the state of Illinois is like, whoa, let's go to 5. Let's not go all the way from 7 to 3. We'll go to 5 first, and now we're going to step down. Also for smaller residential, so multifamily apartment buildings, air changes per hour really gets weird on you the smaller you get, because your surface area to volume ratio starts to skew. And so looking at it and saying, instead we're going to look at a envelope leakage rate and say, how tight is the actual envelope? I don't care about volume, I care about how leaky does the envelope. So, and allowing that, and for more than 7 units, you can actually do a sample. Rather than, I've got 30 units and I have to test every single unit. It takes a while and cost. Sealed crawl spaces. This is one that's come up as far as encouraging sealed crawl spaces. Saying, well, we run into problems with indoor air quality issues, but because now energy recovery ventilators or heat recovery ventilators are now required, or nearly required. You do have to do ventilation. Heat recovery doesn't necessarily have to be that way. Because you have to ventilate, instead saying, well, let me draw the stale air out of the crawl space and pull air from the conditioned space through the crawl space and then vent it out. So I get my air changes, even on days that I don't have any air conditioning. Yeah, this is actually my house here. In a year, I had 27% of the year, 15 minutes of heating and air or less. So if I just had typical ducted ventilation, I'd have a lot of the year that I have no ventilation. So that would be a problem. So this is one option that we look at and saying, if I'm going to ventilate, let's use that ventilation to have that air movement and prevent mold in a crawl space or stale air. Other questions we've got?
This takes effect March.
Anticipated March 1st, 2019.
So if I have a 170 unit building right now, and we have to do Iecc corridor testing, excuse me, can I do sampling on it? Because will still be in construction.
What is your building permit date?
Yeah, that's generally they'll look at your permit date, whether you can,
But technically 2018 is a more stringent code, so can I follow the current more stringent code as opposed to the permit date, which is right now?
It would be up to your code official whether he would allow that, because what you would end up running into is, does the rest of your building meet the 2018? You could potentially end up with a cherry picking situation there and say, I can't say, well, I like this provision of the new code, but I don't want to take any of the rest of it. So it would be something where
That's the local jurisdiction.
it would be up to the local jurisdiction if they want to grant you an exception to allow that. But other than that, they would say, it could be such that they would say, if you want to take advantage of that exception, I have to reevaluate the entire building based on the 2018 version, because you don't get to take that one provision and not the rest of it. So it's not uncommon for code officials to look at it and say, yeah, that kind of makes sense. And again, I think that's a big reason why they changed the definition of approved, was to give code officials much more latitude to say, logic dictates this is right. Yes, I realize on paper it's not necessarily, but it makes sense.
Like the city of Champaign just allowed that. We have to do IDA testing in IDA for blower door compliance, and they want 2015 Iecc compliance. Mm-hmm. But our builder asked the city of Champaign, will you accept resident testing or IDA testing input? Because the city wanted Iecc compliance as well. So they said yes, as long as you're compliant to IDA, and we'll accept that.
Yeah. And then there again, that goes back to having the jurisdictions have some flexibility in, what kind of makes sense. Are we meeting the objective? Similar to that garage saying, does it meet the Iecc, how they say you have to insulate that garage? No, but have we provided something that is equivalent or better? I've met the objective, even if I didn't meet the letter.
I have a question about duct testing.
Yeah.
The way the code reads now, you have to test the ducts if they're in air-conditioned space for 2015.
I believe that is correct.
But then the line under that, or the next section under that, is prescriptive, and you have to meet a particular threshold.
Mhm.
So does that mean that if the project complies with through the performance path, that they have to be tested, but the number doesn't matter?
Yes, that's what it means.
Just checking.
I had a feeling I knew where that question was going. Yes, there is a weird, there is definitely a weird quirk in it. Now, but what they would presumably want to check, is that what your model says that duct leakage is, fits what you tested it at. Because if you put in your model that my ducts leak 2 CFM, and you test it and there's 7, I'm going to run into a problem because, again, your model, presumably your HVAC equipment is sized for that. So if your duct test comes back leakier, I'm going to have a problem with my HVAC equipment keeping up. So, yeah, there is a weird quirk that's like, yes, you have to test it, and no, it doesn't have to meet the standard. But that's a good check is, what did your model say it was? I mean, if your model said 7 and it comes back at 5, I'm good. You know, reality is better than the model. As long as the model is good, I'm good.
It's my understanding that floor door testing and duct pressure testing do not follow performance, so they're mandatory. So you can't offset, at least what you're saying when it comes to duct pressure testing. The test is the test. You can't, like, you can only allow so much leakage.
Now the duct pressure test, the duct leakage test is a mandatory provision. I don't believe, talking here. I don't believe.
Was I misunderstanding? Because I thought that that's what.
Well, I know, and that's where I'm not positive on the building pressure test, if that's mandatory or not. Now, duct pressure testing is mandatory, so no matter whether you're going prescriptive or performance, you have to test the ducts. Now, I believe there is an exception where if it's totally within the thermal envelope, then you don't have to pressure test. But if they leave the thermal envelope, you have to pressure test it no matter what. Now, you have to pressure test it, but it doesn't have to necessarily meet the 4 or 3 CFM per square foot. You have to test it, you have to know what the value is, but it doesn't necessarily have to meet the standard of 3 or 4. It's a really weird quirk. And that's why I said.
See, I thought it had to.
Nope. No, because the 3 or 4 is a prescriptive item, the pressure test is a mandatory item. And that's why it goes back to, you have to test the duct to know what the leakage is, so that you can check your energy model and make sure that your energy model is reflective of reality. Or at least your energy model is at least as tight or worse than they actually test. So if your model said they leak 7 CFM per 100 square feet and you test it and it's 5, you're good. Even though it's above the 3. Because your model said it was worse. And as long as the model passed with the worse, again, you're trading off here. I have more leaky ducts, that means I traded something else to make up for it.
And I didn't think that you could trade off when it came to
performance. You
testing.
Well, not blower
testing,
not blower door. Again, that's why I'm splitting. I'm talking about duct pressure testing.
I
thought blower door is a separate.
I thought it was well. I thought duct pressure testing.
Yeah, duct pressure testing is a separate section from the blower door test. They are related, but they are 2 different sections. So I won't answer the blower door. I won't necessarily answer it right now because I don't know for sure, but because I've run across that duct pressure test one before, and so I know the answer to that. I don't know on the blower door. But if I'd be happy to get back with you on that once I verify that. So again, I don't want to necessarily say this is the answer and then be like, yeah, I was wrong. I try not to do that. But if I do, I'll tell you I'm wrong. All right. Well, if you guys do come up with other questions,